This is Pluto, the world we were told to stop caring about. Once the ninth planet, then suddenly dismissed in 2006 as if it never mattered. They underestimated Pluto. They underestimated what was hiding out there in the dark. Because while the world argued over its identity, James Webb quietly turned its gaze toward this frozen outcast. And what it detected inside Pluto is something NASA never expected, something no model predicted. And now the question isn't why Pluto was downgraded. It's what has been waiting beneath its surface all along. The moment the data hit NASA's screens, the room fell silent. Pluto's shadow wasn't behaving. Its thermal readings dipped, then surged, as if something beneath its frozen crust was moving. Webb kept watching. The anomaly kept growing. Astronomers traded looks, fear first, then disbelief, because these patterns shouldn't exist. Not out here, not on a world this cold, this ancient. Equations failed, models collapsed. What Webb recorded defied every assumption about dwarf planets, internal heat, and orbital stability. Something inside Pluto was generating energy, something rhythmic, something timed, as if the planet wasn't just reacting to the sun, but responding to something deeper in the dark. A pulse, a signal, a hidden mechanism awakening after billions of silent years. And if Pluto is no longer dormant, what else out here is waiting to wake up? The moment the intro ends, the tension does not dip. It sharpens, because the signal James Webb captured over Pluto wasn't a glitch or noise or a frozen world simply behaving strangely. It was the beginning of a fracture in our understanding of outer solar system physics. NASA's internal logs confirm the chain of events. James Webb first targeted Pluto during a scheduled NIR-spec high-resolution pass in July 2025, part of a long-term survey to track minor shifts in Kuiper Belt objects. At 5.9 billion kilometers from the Sun, Pluto receives so little energy that its surface temperature sits around -233 degrees Celsius. Under such conditions, nothing on the dwarf planet should change quickly. No sudden heat spikes, no atmospheric pulses, nothing. But that expectation collapsed during a 42-minute observation window. James Webb NIRS-PEC instrument detected a narrow-band thermal signature, a flash of infrared radiation rising from Pluto's night side. Not broad, not scattered, focused. A spike measuring 3.7% above baseline, lasting roughly 90 seconds before dropping back to silence. For a world that rotates once every 153 hours, with an atmosphere that collapses and freezes as it moves away from the Sun, this shouldn't be possible, and yet the signal existed. The data forced NASA to activate backup cross-instrument analysis. MIRI confirmed a matching thermal echo. Even the Deep Space Network recorded a timing delay in the reflected light curve, so small it risked being dismissed, but too consistent to ignore. It pointed to localized heat beneath Pluto's surface, heat where there should be none. To put this into perspective, models show Pluto's internal heat should have dissipated billions of years ago. No active geology, no cryovolcanism, no upwelling. New Horizons confirmed this in 2015. Pluto was cold, stable, and ancient. But James Webb reading broke that rule. The anomaly wasn't a plume or a vent. It wasn't sunlight scattering off frost. It was energy emerging from below, from a depth no current model can justify. And worse, the spectral trace had a composition unlike any known Kuiper Belt body, a narrow emission line around 4.5 microns, behaving as if something under Pluto was absorbing heat, then releasing it in a pulse, not continuously, not randomly, periodically. Astronomers mapped the flash timings, subtle shifts, spaced roughly 6 hours apart. Too regular to be geological noise, too clean to be a coincidence. The pulse wasn't just detectable, it was structured. That's what alarmed the scientists, because periodic heat emissions on a frozen dwarf planet imply a mechanism, and a mechanism means activity. And activity means Pluto is not the dead world we thought it was. James Webb spectroscopy team ran the data again, then again. Then, through independent pipelines at Goddard and the ESA Science Data Center, the numbers refuse to budge. Something under Pluto is 1. Warmer than the surrounding crust. 2. Cycling energy at a repeating interval. 3. Affecting the atmosphere in brief measurable bursts. This contradicts every thermal model of Kuiper Belt worlds. Even more unsettling was the secondary measurement. NIRCam detected a minute distortion in the shimmer of Pluto's thin nitrogen atmosphere, as if the atmosphere was vibrating, tiny oscillations rising at the exact moment the subsurface heat pulse peaked. These oscillations should not exist. At Pluto's pressure, 1/100th of Earth's, its atmosphere is too thin to support waves of this intensity. Yet the data showed measurable atmospheric displacement. The air moved. Something pushed it, and the heat spike wasn't localized anymore. Each subsequent pulse was slightly stronger, as if the phenomenon was growing or migrating. That's when planetary scientists realized the gravity issue. New Horizons measured Pluto's mass at 1.309 times 10 to the power of 22 kilograms, stable and predictable. But James Webb long baseline observations detected a microscopic but persistent drift, a timing deviation in Pluto's orbital predictability, not enough to change its path, but enough to suggest mass redistribution under the surface. If Pluto's interior is shifting, expanding, or reconfiguring itself, the implications extend far beyond one dwarf planet. Because if Pluto is active, then other Kuiper Belt bodies might be active too. Our entire picture of the solar system's edge, its formation, evolution, and thermal history, begins to crack. Cryovolcanism, subsurface ocean pockets, exotic ices, unknown heat sources? Each explanation only deepens the contradiction. Nothing fits the exact periodic pattern. Nothing explains the energy intensity. Nothing accounts for a heat pulse that behaves with precision. And then came the final detail, the one that pushed the scientific community from confusion to fear. During James Webb's third observation cycle, the telescope detected a new spectral feature, a faint, low-frequency absorption line appearing only in the seconds before each heat flash. A signal that suggests the presence of compressed volatiles cycling under immense pressure. But Pluto doesn't have the pressure for this. Not naturally, not anymore. That signal was the moment NASA realized this wasn't a single anomaly. It was the beginning of something broader, something deeper, unfolding beneath a world we thought was frozen still. And just as the astronomy teams began comparing the thermal pulses and atmospheric waves, a new data package arrived. Fresh readings, stronger fluctuations, a second anomaly. One that shouldn't exist under any circumstances. The science teams paused. Screens froze. Models failed. Because this new signal didn't match the first at all. It was worse. And that's where the mid-script twist begins. And then, without warning, the data jumps again. Webb's infrared stream fractures into a second anomaly, sharper, colder, and far more violent than the first. Not a thermal echo, not geological noise. This time, the spike comes from beneath Pluto's surface, and it's moving. Ground control freezes. ESA deep-range gravimetry shows a sudden dip, a microfracture in local gravity itself, as if something inside Pluto briefly shifted its mass by several kilometers. That should be impossible. Nothing that small, that frozen, that ancient should produce gravitational motion. But Webb keeps tracking it, a faint pulse, repeating at irregular intervals, a rhythm, a signal, something pushing outward through layers of nitrogen ice that have been still for billions of years. Meanwhile, New Horizons archival data, reanalyzed in real time, reveals matching inconsistencies, patterns everyone missed, patterns that should never align with Pluto's structure. The models collapse, the predictions fail. Whatever this is, it isn't natural, and it isn't stopping, because if these two anomalies are connected, the real story is only beginning. And as that shifting pulse fades into the static of deep space, the tension does not ease. It lingers, quiet, cold, suspended between what we think we know and what the cosmos has just revealed. Webb continues watching, tracing every faint vibration beneath Pluto's distant skin, as if the dwarf planet itself is exhaling secrets older than our Sun. Two anomalies, two violations of the laws we trust. Together, they form a pattern we are not ready to name. A reminder that even at the frozen edge of our solar system, the universe is not finished surprising us. It moves in ways our equations cannot hold. It whispers truths our instruments barely detect. And in that whisper lies something humbling. How fragile our certainty really is. How easily a single signal can bend the spine of science. How a world so small, so dim, can expose the limits of our understanding. Because space is vast enough to hide entire histories, and patient enough to reveal them only when it chooses. Not with answers, but with questions that reshape everything we thought was settled. So we listen, we watch, we wait for the next pulse in the dark. If Pluto is breaking its own rules, what else might be waiting beyond it? Subscribe for more cosmic documentaries.